Welcome to the micro communication course. So today we see few micro components. We start with here the waveguide coupling component. So coupling means what? How to excite the waveguide and how to take out the power from the waveguide. That's about it. Waveguide coupling component. So there are the various ways to couple the waveguide, and that types various types are nothing but what we consider the probe coupling. Okay, so we can consider that loop there. Okay, or we will consider the slot. These are the various ways of a coupling the power inside the waveguide. Okay, so that is about a probe, or you can say that a loop or a coupling. So we talk about first here a probe coupling. So that probe, that coupling means what? That is use a device to give the energy to the guide here. Okay, you can say that feed the guide, that is input here, give the input to the waveguide, or we need to take out the power from the guide or remove the energy from the waveguide. Okay, so that is about a coupling here. So we talk about a probe coupling. So probe coupling means what? A small probe is there. That small probe is inserted inside the waveguide. Now this one is about your waveguide. Inside the waveguide, there is a small probe is coupling here. That small probe is nothing but a small section of a coaxial cable that will be inserted inside the waveguide here, and through that a power will be coupled the guide here. That's supposed to be draw here a probe now. This one is a small section of a probe that will be used, couple the power here to the guide, and then when we couple the power to this probe here, there is a section of what you can say that a signal will be coupled to the guide here. So likewise, we are getting the output here. So means if supposed to be we insert a small probe into a guide, then what happens? This particular probe will provide the micro energy to the a waveguide there. With this probe will be act as a antenna here. That small loop or a small probe inserted inside the waveguide, that will be act as an antenna, and then that particular probe, when we provide a signal to the probe here. Okay, signal means what? That is nothing but a coaxial cable, so that's why we are providing the current to the probe. When we are providing the current to the probe, that probe will set up an E field around this probe there. So that's why current flow through the probe, that will insert a E field, okay, here inside the guide. Now that is about the input side. Now then if we use take out the output from this waveguide now, so then what happen here? That probe will produce, okay, that probe will flow the current. Because of that, a field will, okay, field will reach to the probe. Then that field will generate a current at a probe. So that's why this probe will be act as to probe will use to remove power from this guide. Means insertion of a signal or taking out a signal from the, what you can say that, from the guide. So this way we can consider the probe coupling. Now that probe coupling again, at where, at what particular point or at what particular location we are inserting the probe, according to that the efficiency of this particular signal propagating through the guide will be increased or decreased there. So if that probe is located at the center of a rectangular waveguide, then we will get that a highest efficiency. Okay, so insertion, how we are supposed to be insert a guide, insert a probe inside the guide, and then what will be the spacing? Supposed to be this end is a close now. What will be the spacing from this end to this particular probe here? So based on this particular spacing, so we can say that the dominant mode propagating, or we can say that based on this particular spacing, the frequency propagating through this signal, through this guide, will be changes here. Means we can say that a dominant mode means a frequency required to propagate the dominant mode, that will be defined by the spacing between the end of the guide and this particular probe here. And we can increase the power transmitted through the guide using the length of this particular probe. If we reduce the length of the probe inserted the guide, then energy will be reduced. Means energy transmitted through the guide will be reduced. If we increase the length of the probe, then energy transmitted through the guide will be increased there. So similarly, when we take out the power, when we need to take out the power from the given guide, so then based on this particular length of this particular probe, so energy take out from this particular probe, that will be increase or a decrease. So that what we can say here, the size of that particular probe or shape of that particular probe, that will determine the power handling capability of your guide. Again, we can say that at what particular place we are putting that particular probe. So according to that, we say that this probe will determine the frequency also. Means this probe will determine the frequency as well as bandwidth, as well as the power handling capability of your guide here. If we increase the diameter of a probe there, then bandwidth increases. And if we consider that increase the length or decrease the length, increase the length, the efficiency will be increases there. So means again, power handling capability means what? Diameter as well as the length of the probe increases. Means so power handling capability will be increases here. So that is about a probe coupling. Next we can say that a loop coupling. So in a loop coupling, so for a given particular waveguide, okay, now this one is about your waveguide section here. Okay, like okay, supposed to say that this one is about a section here now. Okay, okay, so now this is about a guide now. So now here we supposed to be insert a small section of a loop here. Now this one is about a loop, and that loop is nothing but what? Using the coaxial cable. This one is about a coaxial cable. Means what we can say here. So likewise, this one is about a loop. Just we are going to be insert here. Now this loop, earlier we said that a probe, that is a wire, that probe will produces a electric field here. But here we can say that consider a loop here. So that loop is used to insert that a H field in the waveguide. Okay, magnetic field. So around that loop, the field lines are generated. This one, around that loop, a magnetic field is generated around that loop. Likewise. So if you see here, so likewise we have the magnetic field lines are generated around this particular loop here. A small, whatever the, based on this small section of a loop or size of that particular loop, according to that, magnetic field inserted inside the guide will be increased or decreased. Same earlier we say that capacity. If we say that a loop is a small there, so then we can say that a small power will be inserted. If we say that loop inserted, if it is a size is large, so according to that power will be still large. Or we can increase the power by adding a more number of loops inside the guide. Instead of a single loop, we can use a multiple loop, and so that we can increase the strength of the signal there. And we can increase or decrease based on that whatever the section of the loop here. If it is a small section of a loop, so we can say that we can uh, for this particular small section of a loop, the power handling capability will be less. If we increase the diameter of that loop, if that loop size will be increased there, then power handling capability of this guide or that particular loop will be increased. Then the bandwidth can be increased by increasing the size of the wire, that is the wire size. Whenever we can make the loop there, the size of the wire, according to that, the bandwidth will be increased. So that loop will use to introduce a magnetic field, and then we can say that that is about inserting the power. Similarly, if we take out, we wanted to remove the power from the guide, then loop is used to take out the power from the guide by inducing the current inside the loop. Okay, through the magnetic field, it will induce a current inside the loop. So we will take out the power from this loop here. Okay, so that is about a loop coupling. Then another is about a aperture coupling, or we can say that a slot coupling. So in a aperture coupling or a slot coupling, a small section of a slot is there. Okay, so for a given particular waveguide, so there is a small section of a slot opening here. So this one is about a guide now. This one is about a small section of a slot. It's open here. Okay, likewise we can say that just like a window. Okay, small window. Through that small window, a section of a signal will be coupled here. Okay, so this one window we have small section. So through that, a power will be coupled. Or for a rectangular waveguide, we supposed to be consider that there is a small section. Likewise, this one is a opening here. Okay, small section of opening. So through that, a power will be coupling. We can say that a window or a slot or a small aperture. Okay, so through that, a power will be coupled. So this type of a coupling, so it will couple in a small section of a slot. Your power will be coupled through the small section of a slot there. So this one, earlier we say that there is a loop and there is a probe, but here is a slot that that slot can be used as a that section will be used to remove the power from the guide as well as to insert the power through the guide. Then another component is about a bend. Okay, so we can say that a waveguide bend. So waveguide bend, the means whatever the waveguide we say that the waveguide will bend at sorry e in a electric field plane or in a magnetic plane H plane, in E plane or in a H plane. So based on that bend occurs of a wave to the waveguide in a particular plane. So according to that, that bend is to be named as a E plane bend or a H plane bend. So for example, I am supposed to be saying that For a given particular waveguide, we generally consider that there is a field component. This one is about electric field component, and this one is about a magnetic field component. And now this is supposed to be this one is about our waveguide. Now it's supposed to be bend occur in a E plane side, so it is called as E plane bend. If a bend occur in a magnetic field plane, so it is called as a H plane, H bend. Okay. Now we can see here. So what do you mean by this? E plane, E bend, or H bend here? Can- Now this is called as a what we can say a this one is about a R, that is about the radius of a bend. So this one is about a E bend or a E plane bend. E bend or a we can say that is about a E plane bend. Then so this one is about called as a H plane bend. Okay, that is called as a H plane bend. And now this one is about a radius for this bend. Okay, so this one is about R is about the radius of the bend. So that we can say that for a given particular waveguide, so bend occur. Okay, so bend occur in a given particular plane. So that's why you can say that's about a bend. Now that bend is used to change the direction of power flow whenever we require to connect your waveguide at some particular place or to join another component or join a particular section of the waveguide. So in that case, we require a bend there. And that bend, when we bend the waveguide, so there will be a discontinuity occur at this particular bend. So we need to find out at what particular radius there will be a smaller discontinuity or there will be a small reflection occur through because of that particular bend there. Why this SWR? We can say that SWR or discontinuity occur because of that particular bend. What happened? That group velocity will be changed, and okay, the group velocity depending upon that path. We- That's why there will be reflection occur at that particular bend, or when we join a two waveguide, so power will be reduced. Okay, so likewise. So we need to find out at what particular value of a radius that bend will produce as a low value of a SWR. So for a given particular bend, so there we say that so to avoid that particular discontinuity or a reflection, so in that case we need to consider the mean length between the whatever the that particular bend here. That length of this particular waveguide or mean length between that from this to this here. Okay, so that for the given particular waveguide. So that mean length will be what? Twice n plus 1 and it will be depending upon that a length of the wavelength of the guide there. And that R will be nothing but what? It will be what? 1.5 B for E bend and R is equal to 1.5 A for H bend. Okay, that is about a bend here. Then next is about a twist. So in a twist is nothing but it is to be used to change the direction of a polarization. So twist means what? It will be of a 45-degree twist or it will be of a 90-degree twist. So that twist is nothing but what? That twist depending upon that what will be the wavelength, okay, of a guide. So it can be of what? We can say that a 45-degree twist or it can be of a 90-degree twist. Okay, so now this one is about your, you can say that is about a 90-degree twist. So this one we are supposed to be say that a 45-degree twist. Okay, so likewise, so there that is about a twist. It will use to change the polarization. Supposed to be we want, we have the waveguide. If supposed to be your signal is to be propagating likewise, we want a 90-degree twist likewise. Okay, so 90-degree twist, 45-degree twist likewise. So according to that, if plane now here, if you see that here electric field component will changes to the likewise, so 90-degree twist. Okay, so here, so we say here polarization is depending upon that a field component, or we can say that converting that vertical to the horizontal polarization or horizontal to the vertical polarization, we supposed to use a twist there. Or at particular junctions, we require to change the position of a polarization. So in that case, we use a twist there. Then another is about a transition, or we can say that tappers. The transitions are tappers that are used to couple the waveguide of a different dimensions or waveguides of a different cross sections. What do you mean by this tappers? So if we have a circular waveguide there and we would like to connect the circular waveguide to the rectangular waveguide. Okay, so in that case, we supposed to be consider the tap body. Okay, so likewise, so we can say that this one is about a circular cross section and we have a rectangular one. Okay, from the circular to the rectangular or from the rectangular to the circular. So we can use a, a tapered here. Then now supposed to be, we can say that we have the rectangular now. This one is about a rectangular section here. Likewise, from rectangular to the circular, we require a tapered there. So that is about for for a given particular section of rectangular waveguide or a circular waveguide that we require a taper to convert from the circular to the rectangular or from the rectangular to the circular. Means it will be used to change the mode also. So for a section of a particular waveguide, supposed to be, we say a dominant mode here at the circular is supposed to be T11. In that case, rectangular waveguide dominant mode will be a T10. Okay, so that is about We say a transitions or a taper, so that is used to change the sections of a waveguide or connect a component there. Okay, so that is about a tappers there. Then a matched load. So in a matched load, so what happened here? So given particular section of a waveguide here, supposed to be this one is about a section of a waveguide. So at this particular section, at the end or at this particular section, there is a small section is to be used, and that small section that is about a resistive card or that resistive vein is there, and that particular when your power will be incident at that particular end, particular place of a guide, so this will absorb all the incident power and no reflection from this particular resistive vein will be there. So that is called as a what we can say that is about a match load. Okay, so match load. So this particular section, so it has a two dif- two different tapering is there. So you can say that at this particular end, either section will be tapered or the section will be considered to be a match for the given particular load there. So this one is nothing but a termination. So that termination can be of what a different types. Okay, it's a tapered section. Whatever the tapered sections are there, that will be of a different type. I say it's supposed to be this type of a tapered section. So another tapered section may be a likewise. You can say that this one is about a tapered section. Okay, so likewise. So section tapered section will be a different kind and various types of different tapered sections are used. So that tapered section will use to absorb all the incident power. No reflection will come out from this particular section. That is called as a match load, or we can say that a match termination. Then a tuning screw. A tuning screw, or we can say that a wire or some particular post that is used insert inside a waveguide, and that will create a discontinuity in a waveguide. So discontinuity means what? Sometimes we say that because of small section of a thick wire or something is to be in use inside a waveguide. Okay, so likewise supposed to be screw now. This one is a small section of a screw that is about a tuning screw now. That is used to insert inside the guide. And that section or a tuning particular tuning screw when we insert here inside the guide, so it will create a uh, loading at a particular waveguide. So now where this particular ports or particular tuning screw is to be used and what happened or what happened to the given particular section of a waveguide here. So this particular port when we insert inside the waveguide, so it will behave like a short circuit and then there will be there it will create a capacity effect or a inductive effect. So now how it will create a capacity effect or a inductive? If the screw inside, okay, if the screw is nearer a side of a wall of a waveguide. So now what is about is we supposed to be consider that is about waveguide now. So if we can insert at a central side of a guide, if we consider that a off central, likewise at off this one is about off central, or if you consider that a horizontal bias, that is about a horizontal one instead of a vertical one. So according to that, for a given particular section, if the screw is near a side of a wall, so then what happen? It will cause a greater reflection than the central or a vertical position. If the screw is inserted slightly into the waveguide, okay, so instead of that, so I supposed to be consider that if supposed to be screw is there, that will be inserted slightly. small, okay, small section. If that screw is slightly inserted inside the guide, so what will happen? It will represent as a capacitor. If it is inserted fully, okay, so now this is small section is inserted inside the guide. Now if that screw is inserted fully, okay, here that screw is inserted fully. Now the screw, small section of the screw is inserted. So the what happen here? It will be a capacity effect. Now if you insert a screw fully, so it will create a inductive effect. Okay, so now there is the effect of a particular screw or small section or a port, so that we will get that a small due to that particular small section. So it will affect a it that screw will uh, create a capacity effect or a inductive effect. Then a attenuator, waveguide attenuator. So there are the various types of attenuator. Okay, there are various types of attenuator. So attenuator means what? There will be a fixed one or there may be a variable attenuator. So now in a fixed attenuator, a small particular sheet is to be used, and that small sheet that will attenuate the signal. The role of attenuator is used to reduce the power level. For a given particular waveguide, if supposed to be power level is large, we can use the attenuator in between the section of a guide or section of a line so that your power will be reduced. So the fixed attenuator, so means fixed position of a tapering is takes place. So the tapering means what? At a particular section, a fixed section of a tapering. Okay, so likewise. This one is about a tapering, fixed section. Or we can say that there will be a tapering likewise. Okay, this one, tapering. Or you can say that there will be a single tap, likewise single tap over there, or there will be a double tap, likewise. So using that single tapper or a double tapper, so that signal attenuated through the guide will be a small. Okay, so that is about a fixed attenuation. Means small section is to be inserted inside a guide. Small section is inserted inside a guide, or there will be a small obstacle inside the guide. Through that, your signal will be absorbed here through that particular obstacle, but some signal will be propagating through the guide. So that is called as a fixed attenuator. That length will be a fixed. But in case of a variable attenuator, there will be a section, whatever the we can say that this section will be a variable. So we can use a screw here to increase this obstacle inside the guide. That will called as a variable attenuator. Okay, so that will attenuate the signal through the guide. So that is called as a variable attenuator. So that's all about, you can say that a fixed attenuator and variable attenuator and all these waveguide components. With this, we stop here. So thank you all of you.